それでは時間となりましたので始めたいと思います。フロリーナさんによる Lifecycle LiveData ViewModels インナーワイヤリングのタイトルです。それではフロリーナさんよろしくお願いします。Okay, it's time to start the session. Lifecycle LiveData ViewModels the inner wiring by Florina. Please give a warm welcome to Florina.
Hello, everyone. Can you hear me? Yeah. Hello, everyone. My name is Florina Muntenescu, and I'm a developer advocate at Google. So the thing is that we are constantly trying to solve problems again and again. We want to perform actions in response to a change in the lifecycle status of an Android component. We want to be able to persist UI data across configuration changes. And we want to observe certain values when they're changed. So to solve all of these problems, lifecycles, LiveData, and ViewModels were created. And today, I want to tell you a few things about what's going on under the hood with them. So you are able to implement your own lifecycle-aware components and just work better with LiveData and ViewModels. So we'll start with the lifecycles. So the lifecycle library brings a set of events and a set of states. And you can see this as a graph where every node is a state, and then every arch is an event that leads from one state to another. So, for example, from the initialized state, we get to created when the onCreate event is triggered. The library also provides another extra event, onAny, that will be triggered whenever any of these events is triggered. The architecture components also brings the concept of Lifecycle Owner. So from an object that is a lifecycle owner, you can get a reference to the lifecycle by calling getLifecycle method. We have 4 default lifecycle owners: activities, fragments, processes, and services. So more precisely, the classes that extend AppCompat activity, fragment, process lifecycle owner, and lifecycle service will also be lifecycle owners. And because on some levels, the lifecycle of an activity and of a fragment are similar, I'm going to cover these two together. So let's go over a few use cases and see when each event is sent and when the state is updated. So let's start with this use case, when the activity started and finished. So when the activity started, the state is initialized. When the onCreate method is called, only afterwards the onCreate event is triggered, and then the state moves to create it. After the onStart method is called, the onStart event is triggered, and the state is moved to started. Next, after onResume is called, the onResume event is triggered, and the state is moved to resumed. When the back button is pressed, the events are triggered before the methods. So more precisely, before onPause method is called, the onPause event is triggered, and the lifecycle state moves to started. Before the onStop method is called, the onStop event is triggered, and the lifecycle state is now created. And then before the onDestroy method is called, the onDestroy event is triggered, and the app is now in destroyed state. I think the interesting things actually happen when, for example, when the device is rotated. So let's say that our activity is opened and we've passed through all of this onCreate, onStart, onResume methods. So now our device was rotated. So then onPause event is triggered, the state moves to started, and then the onPause method from the activity or fragment is called. Then the lifecycle state changes to created, and onStop event is dispatched when onSaved instance state method is called. Then the onStop method gets called. And right before onDestroy, the onDestroy event is triggered. So when a fragment or an app.compat activity state is saved via onSaved instance state, the UI is considered immutable. So it's considered immutable until onStart is called. So if you're trying to modify the UI after the state is saved, it's likely to cause inconsistencies in the navigation state of your application. And actually, this is why the Fragment Manager throws an exception if the app runs a Fragment transaction after state is saved. So if you want to work with the UI, check that the lifecycle is at least started. And because we saw that a lot of developers were making these kind of mistakes in saving the state, in Android P, the order of the onStop and onSaved instance state method was changed. So onSaved instance state is now always after onStop. So this allows applications to safely wait until onStop to save persistent data. So actually, fragments are not that easy because they have two life cycles. They have the life cycle of the fragment itself, the one that's returned by calling getLifecycle, but they also have the life cycle of the fragment's view. Because in the case of attached and detached fragments, these life cycles differ quite significantly. So specifically, the fragment view lifecycle can happen multiple times for a single fragment lifecycle. In the cases of detached fragments, the lifecycle of a fragment can be considerably longer than the lifecycle of a fragment's view. So this is why we also have the lifecycle of a fragment's view. And you're also able to retrieve this lifecycle directly from the fragment. So let's look at when these events are called and what the lifecycles are. So of course, these are related to the main methods of a fragment. So I won't go over onCreate, onStart, onResume, and so on. But the ones that we care a lot about are onViewStateRestored and onDestroy view, because these are the ones related to the lifecycle of a fragment's view. So these are the events and states for the events for the fragment lifecycle. So they're pretty much the same as the ones for an activity. But as I said, the view lifecycle is quite similar. So you'll see that onStart is called after onStart, onResume after the onResume method, and so on. But what's important is that onCreate is only triggered after onViewState is restored, because only then actually the view from the fragment is created. And similarly, onDestroy for the fragment's view is called right before onDestroy view, because from there on we can say that the view doesn't exist anymore. So when you're working with the fragment and with the fragment view, keep in mind these differences in the creation and the destruction of the two. So if you're interested in receiving a callback when the fragment lifecycle view is available, consider using this method, the ViewLifecycle Owner LiveData. The class that provides the lifecycle for the whole application process is the Process Lifecycle Owner. So more precisely, it models the lifecycles of all activities combined. So if you care or if you want to trigger some events when your application is in foreground or in background, this is the lifecycle owner that you'll have to use or that you can use. So here's what and when events are triggered. So when the process starts, the onCreate event is triggered and the state moves to created. Next, when the first activity is started, the onStart event is triggered. Then when onResume is called, the onResume event gets emitted. But then, as other activities are added, no other events are sent, because right now our application is already in foreground. But then, as we're sending the application to background, the on-pause and on-stop events are triggered. When the app is again brought to foreground, then the start and on-start and on-resume events are triggered. As you're closing activities, nothing happens. But only once you get to the last activity, things are triggered. So more precisely, when you're getting to the last activity, the on-pause and on-stop events are triggered. But actually, all the events related to on-pause are triggered with a delay, with a 700 milliseconds delay. So this was empirically determined because we've seen that this is long enough to guarantee that the process lifecycle owner won't send any events if activities are destroyed and recreated due to a configuration change. So overall, these are the events that are triggered. So the difference between the activity and the fragment lifecycle in terms of the events that are called is that we don't have any initialize and on-destroy events because these can't map to the lifecycle of the process. Under the hood, in order to get this information, the lifecycle library adds a provider to your manifest. And actually, this is how it knows when the app is in foreground or in background. The last type of lifecycle owner provided by the architecture components is the Lifecycle Service. This is a service class that also implements the lifecycle owner interface. When the onService is created, the onCreate event is triggered. When the onBind or onStart methods are called, then the service moves to the started state. And then finally, when the onDestroy method is called on the service, both onStop and onDestroy events are triggered. You can execute your own actions whenever a specific event is triggered by implementing a lifecycle observer and annotating the method that you care about, the method that you want to trigger, with on lifecycle event and the event that you want to trigger the method on. And then if you want to execute an action whenever an event was triggered, just use the onAny event. If you're targeting Java 8, prefer implementing the default lifecycle observer and overriding the method that you're interested in. But the difference with this is that you don't have an onAny method. So if you do care about onAny, use the other approach. Then make sure you connect the observer to the lifecycle you want to observe. And that's it. OK, but how about making a view object, your custom view, also a lifecycle owner? Well, the problem with this is that views don't have always the same lifecycle. So how should we start this lifecycle? What should be when a view is attached to window or detached from window? When the view is attached to window, is it created? Is it started? Is it resumed? What kind of mapping should we put here? What triggers the change to the next states? If we look at the fragments view, we see that actually the methods from the fragment are the one that dictate the lifecycle of the view, because the fragment is the one that controls when the view is created, when the view is destroyed. So this means that if you think about defining your own lifecycle for the view, you should actually pay close attention to the object that controls it, because that one will be actually the one that should decide when things are created and destroyed. So in the end, this is why we are not providing a view lifecycle observer, because we don't really know what's the lifecycle of that view. But you can also implement your own custom lifecycle owner for whatever cases you might have. The architecture components gives you this set of events and states, and you can decide when you want to trigger specific events and when you want the state of your lifecycle to move to different from one to another. So you can also implement your own. So this means that because you have all of these kind of life cycles, you can implement your own lifecycle aware objects. So these objects that can contain logic that you would usually put maybe in an activity on resume or in service on bind. This kind of logic can be moved from those classes to separate classes, to smaller classes that do only one thing, handle specific cases related to life cycles. And then these are small classes that can be easily replaced, that can be easily tested. Okay, so in our case, we implemented such a lifecycle aware component. And this is LiveData. So let's go over LiveData and some of its subclasses and functionalities. So LiveData is a lifecycle-aware data holder. It means that the data can be set on a LiveData by other objects, and then data can be observed in the context of a lifecycle, the life cycles that we've been speaking until now. For example, the place where, or the reason why LiveData was created was to work with the UI. So chances are you would observe your LiveData and you would update your UI accordingly. So in the case of an activity, for example, when the activity is recreated, is on pause, then LiveData is inactive. But then when the Lifecycle Owner is started or resumed, then the LiveData is again active. So this means that only when LiveData is active, the changes to the LiveData, so to the data that's being held by the LiveData, is propagated to the UI, to the subscriber. So the LiveData subclass that allows you to set values is mutable LiveData. And you can set values either using the post value or set value method, depending on the thread that you're calling this from. You would use post value when you're calling this from a non-UI thread. So by default, LiveData is emitting these events on the main thread. That's something that's really important and you should be aware of. Then you would just observe the LiveData and then react on the changes. So actually, under the hood, LiveData just has a list of observers that get notified when something has changed with the data. That's all. So by default, we have 3 different types of transformations: map, switch map, and distinct built-in changed. I won't go over what they all do because I think the documentation is quite good about this. But rather, I want to tell you how you can implement your own custom transformations. So to do that, let's try to implement a merge. So let's say that we want a LiveData to merge the emissions of 2 objects. That's all. So to do this, we would use a mediator LiveData. So we would define our LiveData 1 and LiveData 2, our sources. And then we would just add those as sources to the LiveData merger. And then every time, for example, LiveData 1 has emitted a value, we're just setting that value to the LiveData merger. That's all. So actually, also, if you look at how map and switch map and so on are implemented, you'll see that they all use this mediator LiveData. So whenever you feel like you need to do some transformations that are not available already, check out this mediator LiveData. One of the questions that I get quite a lot is whether LiveData is supposed to be a replacement for RxJava. But let's look a little bit at LiveData. LiveData is actually just a data holder. It doesn't have any terminal events as the Streams API does. But most of all, LiveData works with a lifecycle. It was specifically designed to be that communication bridge between a view model and the UI, between that UI logic and the UI. So I don't think we necessarily need to look at LiveData or RxJava, but rather think about using LiveData and RxJava. So for example, this is why we created the LiveData reactive streams. It's a small library that provides two methods. One that allows you to go from a stream to a LiveData, and then another one that allows you to go from LiveData to a stream. Okay, let's go to the view model. The role of the view model is to get the data from a business layer, so from a repository, for example, to prepare it to be displayed by the UI, but then also to handle the user's actions and to forward that to the classes that are needed. What I think it's important to remember is that the lifecycle of the view model is connected to the lifecycle of the activity or fragment. So more precisely, the view model is destroyed when the activity or fragment is completely destroyed. So this means that the view model will survive configuration changes, but it won't survive things like pressing back, killing the app, for instance, or when the framework kills your application. So when the view model is destroyed, the onCleared method is called. So this means that the onClear is the point where you should be unsubscribing from any listeners, or you should be canceling any requests that you might be making. And actually, the onClear method is the one that our coroutine support is using. So if you're working with coroutines, then you know that you need to launch coroutines in a scope. So we created a new KTX artifact, Lifecycle ViewModel KTX. And this one adds a ViewModel scope as an extension property to the ViewModel. And the scope will be canceled when the ViewModel is cleared. So this means that you'll be able to launch your coroutines to, for example, trigger a request to a backend. But then when you're exiting that activity, that request will be automatically canceled, or that coroutine, sorry, will be automatically canceled. The ViewModel scope is bound to dispatchers.main. So this means that you have to make sure that you're switching context whenever you're doing any long-running operations. So lifecycles, LiveData, and ViewModels were created to allow you to build scalable, testable applications with lower amount of boilerplate code. And via the KTX artifacts to be as Kotlin-friendly as possible. So make sure you migrate to Android KTX and take advantage to the latest features of these libraries. Thank you.